All right, guys, welcome to week 2 of Smart Acids production. This week, we're going to be talking about proteins. Question number 11. In insulin, 2 peptide chains are held together in a single unit by A, disulfide bridges, B, a beta-pleated sheet, C, salt bridges, D, a prosthetic group, or E, hydrogen bonds. Let's take a look at insulin. Insulin is made out of 2 amino acid chains, and these chains are held together by 2 disulfide bonds, just as shown in this picture. So let's go back to the question for a second. We clearly see that the answer is A, disulfide bridges, but let's just take a look and see why it's not the rest. A beta-pleated sheet forms a secondary structure of proteins, so that can't be the answer. Salt bridges are a combination of hydrogen bonds and electrostatic interactions. Prosthetic groups are cofactors that bind tightly to proteins or enzymes. And this is just a simple hydrogen bond. So we can clearly see that in insulin, 2 peptide chains are held together in a single unit by disulfide bridges. The answer is A.
Next question. Number 12. First, we have to understand what an ionized form is, so let's look at that. Ionized forms of amino acids. An amino acid may have an overall neutral charge that forms only at a specific pH or isoelectric point. They can exist as a positive ion if the solution is more acidic than its pI, or they can exist as a negative ion if the solution is more basic than its pI. This is an example of a generic amino acid. On the left, we have the neutral, non-ionized form that is not in solution. On the right is the ionized form in solution. As you can see, the R group remains unchanged, while the carboxyl and ammonium groups have a charge. Let's look at serine non-ionized. You can identify the R group with the OH hydroxyl attached, and as you can see, there's no charge. Here we have serine ionized. Both the carboxyl and ammonium groups carry a charge now. The R group remains unchanged. So let's go back to the question. The R group for serine is CH2OH. In the ionized form, serine has the structural formula blank. And as we can see, A is serine in its neutral, non-ionized form that is not in solution. So this cannot be correct. For B, it shows the change in the side chain. The ionized and non-ionized form of an amino acid is based on its carboxyl and ammonium group at its backbone, and not its side chain R. If for any reason the side chain changes, the amino acid would be different and not a form of the original amino acid. This means B is not correct either. D is a positive ion at low pH, and E is a negative ion at high pH. So the correct answer is C. Thanks for watching. See you next week.